Hey there, all you cool cats and kittens. This is Coach Romero from Algebra 2 Rescue, coming at you with our linear programming practice. This first one says to name the coordinates of the vertices of the feasible region and then find the maximum value of the given function p. So first, to find the vertices, we're just looking for the corners. Let's see if I can get a good pen here. So right there is one of them that's at 0, 0. We got another one here at 2, 0. And we got another one here at 3, 5. And finally one here at 10, 0. Sorry, 0, 10. Oops, that's bad. 0, 10. So now we just need to take turns plugging these in up here for x and y, and see what value that gives us. And then we're looking, in this case, we're looking for the maximum. It's asking us for the maximum value. So if I plug in first a 0 for x and a 0 for y, I get 2 times 0 plus 3 times 0, which just ends up giving me 0. If I plug in a 2 for x, so 2 times 2 plus 3 times 0, I end up getting 4. If I plug in a 3 for x and a 5 for y, 2 times 3 is 6 plus 15 is 21. And then at 0, 10, I get 2 times 0, which is 0. 3 times 10 is 30. So it looks like our maximum value is 30, and that occurred at this vertex, which is 0, 10. Come on. There we go. This next one here, our corners are at 4, 0. And we got one at 8, 3. And we got one at 2, 7. And we got one at 0, 3. So again, let's take turns plugging this up in here. If I plug in a 4 for x and a 0 for y, that's 4 plus 2 times 0, which gives me 4. If I plug in an 8 and a 3, that's 8 plus 2 times 3. So I'm going to just write this shorter because I'm running out of space. That's 6, which is 14. 2 plus 7 times 2, which is 14. That gives me 16. And then 0 plus 2 times 3, which is 6, gives me 6. So here the winning number is 16. 16 is my maximum value, and that occurs at 2, 7. Okay. Let's graph the inequalities and then name the coordinates of the vertices of the feasible region. Last week we worked on some review of how to graph linear inequalities. So in order to save time on this video, I have recruited my assistant Desmos to help us out here to try to make this quicker. They're going to do the graphing for us. It also makes it look prettier. My handwriting is not the best. So let's see what we got here. The first one we want to graph is x greater than or equal to 1. Then we want another one that says y is less than or equal to 6. And then we need another one that says y greater than or equal to x minus 2. So we're looking for the region where this overlaps. Let me see, does that give me an option of axis, x-axis? Man. All right. Well, I can see the overlap, and the overlap is occurring. Let's see. They want us to graph the system of inequalities, name the coordinates of the vertices of the feasible region, and find the maximum of the given function. All right. So let's see. The overlapping regions. Here's one vertex right there. That's at. They tell me it's at 1, 6. Maybe I can zoom in a little bit. There you go. That makes it look better. Okay, so we got one at go. No. 1,6. And we got one here at 8,6. And then we got one down here, which is kind of strange because usually we don't see negatives, but there's nothing here that's they don't define what X and Y are, so we don't know that it can't be negative. So let's put a 1 and a negative 1. Yeah, because this triangle here in the middle, I can't draw on that, but the triangle where we see all the shading, that's where the overlap is occurring. That's the feasible region. So now let's plug in these numbers here into the profit equation. It's also known as the objective function. First, 2 times 1 is 2. Then minus 6 is negative 4. Plug in the 8 and the 6. So 2 times 8 is 16. Minus 6, that gives me 10. Then plug in the 1 and negative 1. 2 times 1 is 2. Minus negative 1 is plus 1, which is 3. So our maximum value is here at 10. And that occurred at the vertex 8,6. Okay. Let's move on. Come on, move up. All right. That should work. All right, so let's now plug it. Let's do number 4. X greater than or equal to 0. Y also greater than or equal to 0. Then we got X plus Y. If you were to graph this on your own, you'd probably want to solve for Y. X plus Y less than or equal to 7. And finally, this one has one more constraint. Y less than or equal to 2. Oh, where's my fraction bar? Come on, fraction bar. Let's try to divide. There we go. Divide. Oh, it's negative. Son of a gun. Negative 2 over 3. X plus 6. Alright, so let's see where all these guys overlap. Let's see. So X greater than 0 is to the right there. And this one is up. So far we have the upper right. Here, this purple. Then we throw in some green. The green overlaps with the purple here where this triangle is. And then finally this last one, which was less than or equal to. So it's going to be here, this bottom portion, which I can't draw on it, but I can write the vertices. One of them is going to be at 0, 0. We're looking for this dark, kind of bluish region that's above the x-axis and to the right of the y-axis. So I see 0, 0 as a vertex. I see looks like 7, 0 as another one. Then over here towards the top, I kind of see 3, 4, 3, 4, 3, 4. Sorry for the handwriting. You can just write it in your own handwriting better. And then finally 0, 6. So I'm going to plug those values up into my objective function. 3 times 0 is 0 plus 0. So 0 plus 0 is equal to 0. That's not very big. Plug in 7, 0. 3 times 7 is 21 plus 0 is 21. Okay, not too bad. 3 times 3 is 9 plus 4 is 13. And finally 0 times 3 is 0 plus 6 is 6. So our winner for maximum value is 21. If they were to have asked us for a minimum value, occasionally you might see that. Then we would have gone with 0, but the maximum value is 21, and that occurs at the vertex 7, 0. Okay, let's go on to the last page. Let's see, we got x greater than or equal to 0, y greater than or equal to 2. These are all things we should know how to do already, how to graph linear inequalities. Y. Where's the Y? Y. Nope, didn't want that. Y less than or equal to 6. Okay, which is, so those are both horizontal boundaries, the two with the Y's. So far, the first one is everything to the right of the Y-axis. Then the second one says I have to be above that 2, kind of what's purple now. But then this next one says, whoa, hold on, now you got to be below 6. So far I'm going with the region that looks the most purple of all. And then finally the last one says 2x. Again, if you were to graph this on your own, you'd probably want to solve for y. Ooh, now this is black. Alright, so we're going for the darkest region, which is, and there's no way for me to show you with the mouse here, but it's above the 2. Here, I'll just write the vertices and then you can follow along. Let's go here. So let's write, we have one vertex at 0, 2. We have another one at what appears to be 5. Let me make this a little bit smaller so that they're only counting by ones. Yeah, that's better. So we got another one at 5, 2. Shading in the darkest of all the sections. Another one at 7, 6. And then finally one at 0, 6. Those are the corners. So when I plug in those corners into over here with the x and the y, 4 times 0 is 0, minus 3 times 2 is minus 6, so we get a negative 6. I plug in a 5 and a 2, 4 times 5 is 20, minus 3 times 2 is 6, that gives me 14. 4 times 7 is 28, minus 3 times 6, which is 18, that gives me 10. And then 0 times 4 is 0, minus 3 times 6 is 18, that gives me negative 18. So if I'm looking for maximum, that would have, sorry, if I'm looking for minimum, that would have been the minimum, but I'm looking for maximum. My maximum value was at 14, and that happened at my vertex 5, 2. Okay. Alright, let's go back and let's do the number 6. X greater than or equal to 0, got it. Y greater than or equal to 0. You can graph these on your own paper if you wanted to. We should all know how to graph linear inequalities by now. X plus 2y less than or equal to 10. And then y less than or equal to 1/2 x plus 3. Alright, so let's go region by region and see where this. So we got everything to the right of the x-axis right now. Then we go above the y. So we're looking at what's purple right now. Then this is even, is there a way to change that color? Oh, nice. Alright, let's go like green or something. See how that would look. Alright, so there's where the overlap is occurring. Looks like a triangle right now. And then finally this last one, maybe black. Let's just make it real dark. So we had this triangle before, but then we want to go below that. So what we have here is kind of like, I don't know what you say, it's like a diamond kind of shape. I'll write the vertices. So we got one at 0, 0. Then if you go up the y-axis, it stops at 0, 3. Then we come over to 2, 4. And then we go all the way down to 10, 0. That's the other corner. Okay. Let's plug these in to the profit equation. 0 plus 0 is 0. So that's not going to help. Then we got 0, 3. So 3 times 3 is 9. So 0 plus 9 is 9. Then we got 2 and 4. So 2 plus 12 is 14. So far we have 0, 4, and 14. And then finally 10 and 0. That's 10 plus 3 times 0, which is 0, is 10. Our winner is 14. Our maximum value is 14, and that happens at the vertex 2. Oh, come on, let me write it in. At 2, comma, 4. Okay. And then finally now the last one on the worksheet. We got x greater than 0. We got y greater than 0. X plus y is less than or equal to 6. And then y is going to be greater than or equal to, so now we're going to be on the high side. Greater than or equal to 2 over 5. 2 over 5x minus 1. Alright, so if we take off this black side, so it looks like the shaded region before we enter that last constraint was this triangle that you see here. This kind of greenish triangle that you see above the x and to the right of the y. But then now when I put in this last one, I go above that. So now my corners are at the origin at 0, 0. Then I got another one. Well, it's hard to see there, but luckily I have Desmos. Mr. Desmos is going to save the day. 2.50. 2.5 comma 0. And then I got another one at 5, 1. And then finally, oh come on, wow, that zoomed way out. And then this last one is going to be at 0, 6. Okay, so 0, 6 sounds good. All right, so let's take turns plugging these into the profit equation, which again is over here. 5 times 0 plus 2 times 0 is 0 plus 0, which gives me 0. 5 times 2.5 is 12.5 plus 2 times 0, which is 0. That gives me 12.5. 5 times 5 is a big one. 25 plus 2 times 1, which is 2. That gives me 27. So far, that one's in the lead for maximum. And then 5 times 0 is 0, plus 2 times 6, which is 12, is just 12. So our winner is 27. 27 was our maximum value, and that occurred at a vertex at 2.5. So that's a point 2.5 comma 0. All right, thank you guys for watching.